In this video, I'm going to talk about acidic and basic salts. So when you take an acid and a base and you put them together, so let's say HCl is our acid and we mix it with NaOH as our base. What happens is that a neutralization reaction occurs and our positive and negative ions separate like this. And the front positive part of the base is going to connect to the negative part of the acid. So these two are going to combine, and the front of the acid will combine with the negative part of the base like that. So we end up getting Na with Cl. Remember to write the positive one first, the metal first, so NaCl. And we get H with OH, which is just H2O. So we get a salt and we get water. And you would think that this salt would be neutral, and sometimes they are, but sometimes they're still acidic and sometimes they're still basic. So in this video, we're going to talk about how you determine which type it's going to be. You have to sort of work backwards. So once you have your salt, let's say our salt is BaF2. So we have to figure out, well, what acid and what base did this come from? And were they strong or were they weak? And I have another video tutorial on determining the strength or weakness of an acid and base that you may want to watch if you need to review that. So remember, our Ba came off of the base. So we're going to put OHs on that. Well, Ba is here in column 2 of the periodic table. So when it becomes an ion, it has a +2 charge. OH is a -1 ion, so we need 2 of those to balance out our Ba. So this is our base. Acid, we have F. F is our negative ion here. It's a halogen right next to the noble gases, so it has a -1 charge when it's an ion. So since it has a -1 charge, we need to put 1 hydrogen on it to balance it out. So HF is our acid, and BaOH2 is our base. You're always going to get the base from the front ion and the acid from the back. You put OHs, however many you need, to balance the positive charge on your front ion. And for the acid, whatever the charge is on the negative ion, that tells you how many hydrogens to add to balance that out. Now, Ba is in column 2, as we said, and bases made from these metals in the second column are always strong, which means a strong acid means it comes apart completely when you put it in water. It dissociates or separates into its ions completely 100%. HF, well, as we said, F is in this column, but the only 3 strong binary acids are HCl, HBr, and HI. So HF is actually a weak. If we have a strong base combined with a weak acid, the strong base will overpower the weak acid, and so we're going to have a basic salt because the base was strong, overpowers the weak acid. So this salt right here is a basic salt. We're going to work some more examples. You may want to pause the video for each one, and then you can see if you can figure out whether it's a strong acid, strong base, what type of salt you get from it. And after that, you can hit play and check your answers. All right, let's say our salt is AlCl3. So we're going to separate this into its two ions. Al is here in the third tall column. 1, 2, this is the third tall column, column 13. And these top two elements here have a +3 charge when they become ions. So our Al is going to be a 3+ ion. Cl is a halogen, just like the F was. It's in this column, and this column ionizes to a -1. And so to make these into their acids and bases, remember the front one becomes a base, so it's going to be Al. And then we're going to put 3 OHs, because each OH is a -1. We need 3 of them to balance our +3. So that's going to be our base. Cl is -1, so we need 1 hydrogen on it, and this is going to be our acid. Strong bases, the metal comes from the first two columns. Well, Al's way over here in this column over here, so this is a weak base. HCl, there are 3 strong binary acids, HCl, HBr, and HI. So it is one of the 3 strong acids. So because one is weak and one is strong, the strong one overpowers. And so since the acid is the thing that's strong, that means that this is an acidic salt. And what that means is if you dissolve this in water and check the pH will be lower than 7, because lower than 7 is acidic. Let's try another one. Okay, so here's our salt, KNO3. K is in column 1 of our periodic table, so it's going to ionize to a +1 charge. So it's going to need 1 OH on it to balance it. That's our base. NO3 is our other ion. NO3 has a -1 charge, so we need 1 hydrogen on the front to balance that out, and that is an acid. Now KOH, remember that if the metal in the front comes from the first 2 columns, then it's a strong base. So K is right here in the first column, so this is going to be a strong base. HNO3 is a ternary acid, and the way that we figure out if this is strong or weak is we take the number of oxygens minus the number of hydrogens, and it has to be 2 or more to be strong. So our number of oxygens is 3, our number of hydrogens is 1, so 2 is a strong acid. Well, now we have strong base and strong acid. So they're going to completely neutralize each other, and this will be a neutral salt. So now you've seen one of each type. I hope this has helped. Come back and watch other videos, and have a great day.